So, morning everyone. Thank you for joining. It's a fresh morning, and right now you all must be fresh and ready to learn and grasp something new today and implement. I'm sure you will be implementing this at your home or at your work after going back. I will be talking on making cloud native greener, mitigating environmental impact with Kepler, Kube Green, and beyond. So, this topic is away from the political aspects. This topic is more onto the technical aspects of environment. In this talk, I will be talking about what you can do in order to make CO2 emissions less, and which tools you can use to measure the CO2, the energy consumption of your clusters, of your pods, and how you can reduce the CO2 footprint. So before moving on, I would like to ask you all, currently are you implementing some of the tools onto your projects, or you are working in some way to the CNCF sustainability? Any one of you is currently working on such project? Oh, that's nice. Okay. So we can see the awareness right now. So this is why I am here, to create awareness. I am Saloni Narang. Currently, I am working as a contractor in Expanso. I am KCN and DCA certified. This is my Twitter handler. Please do tag me if you will come across such tools or some of the technologies or the projects which are contributing to CNCF sustainability. Because I am also new to this space, I am still exploring this space, and I really want to be aware of such products or projects. This is my LinkedIn profile. Do connect with me. So let's get back to the school days, and first I wanted to set the context right, like what sustainability is. So by definition, it is the ability to exist and develop without depleting natural resources for future. So this is very basic thing every one of you must be knowing, but today I will be focusing more on the technical aspect of it, about how your pods, how your clusters, how much your system is consuming the CO2 emissions, and how much energy your product is taking. And I'm sure you'll go back and talk to your team about this. Before moving on to the sustainability CNCF tag sustainability, environment sustainability, I would like you to tell you what Technical Advisory Group is. So Technical Advisory Group comes basically under TOCs, and they provide technical guidance across section of projects in CNCF landscape. So they guide you like which project should come under which tag group. There are many tag groups available, so I will be showing that as well. So they guide you, they give you technical guidance, and they give you relevant idea like how you can work on which project, and which project can come under which group, which tag group. They review your project, incubating projects, and graduated projects. They do everything, and they provide valuable feedbacks. And they answer your questions. So this was all about Technical Advisory Group. So there are many groups under this. So a few of them, as you can see, there are these logos out there. This is for tag security. We have tag contributor strategy, tag runtime, tag observability. So these are all the groups, and under these groups there are several projects. So tag storage is one of them, but in today's talk I will be focusing on tag environmental sustainability. So this is the main agenda of the talk today, to create the awareness about the tag environmental sustainability, as this is the very new group in CNCF, and this year in KubeCon EU, many talks were around this. So I came to know about this in the KubeCon. And you can also contribute to Tag Environment Sustainability. There are meetings that go on every Wednesday, I guess. You can visit the GitHub of Tag Environment Sustainability. There is GitHub for this, and you can also contribute to it. So what basically Tag Environmental Sustainability does? So they advocate you for the open source project. They define certain rules, like which project, how you can calculate. They give you a few standards, how you can calculate CO2 emissions, and how you can also, they give you feedback on how you can reduce the carbon footprint. And obviously they are raising the awareness of environmental sustainability. So this is what Tag Environmental Sustainability does. So there was this survey that was held by CNCF Tag in 2022. As you can see, there were around total 49 responses, and it was there in the market for 5 weeks. So there were responses, 7% of the responses from the Europe and 24% from the North America. As you can see, the gray area out there, it is for 36.7%, and it is the company size. Like, this was hugely from the software technology. As you can see there on the another pie chart, the greener one, the most of the feedbacks were from software technology. So this was all about the participants and demographics that was there. Now coming on to the question. Why I'm sharing this survey with you, just to let you know that how much people are aware of this sustainability and the emissions of CO2 which your product, which your clusters, which your pods does. So that is the reason I'm sharing this, like how many organizations know about it, how many organizations are working on it. So this was the fourth question which was asked is, how do you consider sustainability within your systems, architecture and solution design? So as you can see, there were 55% people who focus on the software best practices, but also there is huge percentage which do not consider it at all as well. So that is a big thing, and that is a change which we are here for. We want to really make everyone aware and everyone work on this sustainability thing. Also, this was the fifth question which was asked, how do you collect metrics regarding carbon use? So that is really sad, but 1/4 of them really do not track the data. They do not track how much carbon emission is happening, and many people are not at all aware of this carbon metrics. And this was another question, what sustainability related metrics do you collect for your infrastructure? So 40% of them don't collect any sustainable related metrics. So there will be some more of such kind of surveys happening in future, just to have a correct metrics and just to see whether we are working on the correct direction or not. So this was not the end point here, but the starting point of sustainability. So this was all about what is TAG, what is CNCF sustainability TAG. Now I will be talking about the tools which you can implement onto your projects, onto your work, and you can go back and work. So there are a few tools I'll be talking about. One of them is Kepler. So what is Kepler? Kepler is CNCF sandbox project, and it comes under sustainable computing. It basically helps you to calculate CO2 emissions, and you can see it very perfectly onto any fancy dashboard, that how much carbon emission is there, and how you can do it, that also we will discuss. And yeah, so Kepler is Kubernetes-based efficient power exporter. Under the hood, it uses EBPF technology under the hood, which is another very strong technology. You might be aware of it. It lets you run your programs onto the kernel level. Then, after collecting all the data, it presents the data to the ML models, which can be online, offline, anything. And then again, this is presented in a presentable mode by using Prometheus metrics. And then you can use any fancy dashboard to see how much carbon emission is happening. Now let's see how your pods is emitting CO2 and how the energy consumption is happening. So as you all know, this is node. The bigger one is node. Then we have pods. Inside pods, you can have one container or more than one container running. So everything that is running on kernel level are contributing to energy consumption. So as you know, that containers are Linux processes, and Linux processes run on their, like, having namespace, and also they also contribute to energy consumption. Whether it is CPU, RAM, GPU, everything that is running leads to energy consumption. So there are certain ways, there are certain workarounds how we can measure the energy consumption, emission, CO2 emission, but we cannot measure it directly. So there are certain workarounds how we can do. We can measure capacitance and frequency. So capacitance is basically number of circuits running, which can be measured using the number of CPU cycles. And then there is frequency. Frequency, every circuit frequency. This can be measured using counters, CPU counters like APerf counters and these things. So this is how we can measure the energy. So in Kepler, what is happening is, as I mentioned, it is letting you know in a perfect metric, in a it collects the data and let you know how much energy is consumed. So this is what the architecture looks like. So here the matrix is produced twice in here. So what happens is, this is eBPF program, and it is attached to the trace points and perf counters. This is the process name, then container ID, perf counters, stats are there, and these goes into Prometheus, and then from there it goes on to the ML models, which lets you calculate in a smart way how much energy is consumed. So this is online learning model server, and then again the energy estimate model goes back to the Prometheus, and it gives you a perfect matrix which you can view using any fancy dashboard like Grafana and all. So this is how the Kepler architecture looks like. So what you can do is you can go back and read Kepler metrics overview from the document, and there are certain deployment strategies, no sidecar, with sidecar, online ML models, etc. You can go through from the documents, and you'll get to know more about this tool. And this tool is really helpful in terms of measuring the energy consumed by your pods. So this is just a small screenshot which I have taken. So this is how the dashboard, Grafana dashboard, looks like. The data generated by Prometheus and using ML models, Kepler basically. So this is Kepler exporter dashboard. So it is telling you the carbon footprint in namespace, how much it is. This is CO2 coal, this is for petroleum, and this is for natural gas. So these are the carbon emissions. And this is how the dashboard looks like. So let's quickly go through the summary of Kepler. How Kepler works is, first of all, Kepler lets you know the energy consumption by pod. It captures, eBPF helps you to capture the matrix, and then it sends it to the ML models. It can be online and offline. Then it generates some meaningful data for you. And then you can view those data as I have shown here onto the fancy dashboards. So this was all about how you can measure the CO2 carbon footprint. This was all about this. But now what you can do to reduce the energy consumption from your side. So you can use tool like Kube Green. This is I found this tool very interesting. I'm still learning how Kube Green works. So Kube Green is operated to reduce CO2 footprint of your clusters by reducing your deployment, scaling down your deployments. You can set your pods, you can make your pods sleep whenever they are not required and awake them when they are back in use. You can do these things using Kube Green. So how many of you think that thousands of pods and all of the pods are required running 24/7 in your dev, stage and prod environments? So as you all are aware that we have these environments, dev, stage and prod, but do you think we need thousands of pod running onto these environments always 24/7? Because they are contributing to CO2 emissions and there are multiple clusters. So what we can do from our side is we can set few pods to sleep in dev and stage environment. I'm not talking about production. Yes, of course, we need them running all the time there. But how about dev and stage? We can make them sleep for certain time. This is what Kube Green helps us. And whenever we need them back, we can set them, get them, like we can tell them, get up, get up. So this is what we can do from our side. So this is a small illustration I have taken from the Kube Green site. This data has been taken from a paper, goclimate.com, and this lets you know that these are few of the assumptions that has been taken from GoClimate, and it tells you these are the assumptions: cluster node of 2 CPU and approximate 1 node is 1 server. These are all the assumptions that has been taken, and 15 pods per node. So this calculator is telling you when you are using Kube Green how much CO2 emissions you can reduce, and when you are not using it, what is the CO2 emission. So as you can see, CO2 per pods per year is 11 and total number of pods are 100. Total number of pods are 100 when Kube Green is active, and this is the hour of sleep per week, 128. So without Kube Green, CO2 is 21, and with Kube Green, it is 5. So there is total difference of 16 that we can make using Kube Green. When you are installing Kube Green, this much effect, this much impact you can create to the environment in a technical way. So now let's come and see how the admin can define CR. Just simply install Kube Green, and this is operator installed on Kubernetes, and this is how the CR looks like. So this is kind, that is sleep info, and the spec looks like this: weekdays. You can define when, at what time, and on which days you want your pods to sleep, and it is like 1 to 5. So it is for 5 days. And sleep at, it is you are making your pod sleep at 8 p.m. and wake up at, it is 8 a.m. You can also define the time zone. So time zone is Europe, which is defined here. And you can also suspend the cron jobs, the resources over here. It is set to true. And this is exclude reference. So if you want certain deployments to exclude, you need to mention here under this exclude reference. Otherwise, all of your deployments go onto the sleep. So this is how the CR looks like And this is how you can save the energy consumptions for the 5 days onto your development and staging environments. And this is sleep at, you can make them sleep. This is wake up at. So this is how it looks like. These are the resources which you can work on. This is deployment, and these are cron jobs. You can set the sleep and wake up time. So replicas can be set to 0. And what is wake up time? The replicas will be automatically set to the number which you have defined before sleep. Basically, these are saved in a secret with the name of sleep info in the namespace. So this is how you can do for the cron jobs as well. You can define the sleep and suspend, set it to a suspended, and suspend field removed for the wake up thing. So this is how the Kube Green works. And a small summary for it, for these tools. So from Kepler, what we learned is we measured energy consumption per pod. And from Kube Green, you can take action in reducing your carbon footprint by scaling your deployment to 0. So there is one of such tools, which is Bucklehow, which is also working and contributing to sustainable environment. This is another tool for cost efficient, which is cost efficient. This is for secure computation. It works on COD and it is very fast. And how it fits into sustainability is, in this users can select the providers that match to their green portfolios. You can pack your jobs tightly, and therefore you can reduce and save your energy and space. And you can also give permissions and enable and that are enabling to organizational climate change companies, and which are sharing data and collaborating on the research. And as I mentioned, it works on compute over data architecture. So currently this CNCF tax sustainability is very new, and I would like to know more about you. I would like to hear more about from you. Please let's catch up and see how we can do more on this and how we can contribute more to this TAC project. And yeah, thank you. Any questions?
Thank you, Saloni. Do we have any questions? Okay.
A small question is, have you heard about Green Computing Foundation?
Yeah.
I was wondering if the working group is collaborating with that foundation as well, because they are doing some RFCs or way of calculating things, and it seems from the sustainability group they're doing other type of so there's two different way of doing it, and I was hoping that someone is building an official RFC on how you can calculate carbon footprint, because there's two way of doing it at the moment, and I don't know where it is at the moment. Do you have any idea on this?
No, I do not have any idea on this. As I mentioned, I'm also new onto this, but we can always contact CNCF Tag Sustainability Group and ask them, and they are very helpful and they are ready to answer our queries, and I'm sure they must be knowing about green computing.
Thanks for the question. Anyone else? All right, well, you had all the contacts for Saloni. If you want to get in touch with them, let's give a big round of applause. Thank you.